Hi, in this video, I'm going to talk about the data link layer and specifically about accessing the media. Okay, so one of the things that the data link layer is responsible is for accessing media, MAC, Media Access Control. And there's, depending upon the protocol, the technology, whether it's Ethernet and whether or not you're using full duplex switches or half duplex hubs, and we'll talk more about that when we get into Ethernet. A little bit more in another video coming up in this playlist, but a lot more when we get into Ethernet. But there's different rules for how we actually access the media. You know, it's kind of like being in the classroom. What's the rules for asking a question? Do you raise your hand and then wait to be called on? Or do you just yell out the question? What do you do if two people raise their hand at the same time? Or what do you do if two people are calling out a question at the same time? So in networks, we have rules for how we actually access the medium. Okay, so I mentioned MAC, Media Access Control, and we're going to focus on two different topologies, what we call point-to-point and multi-access. So multi-access, by the way, is what we think of with Ethernet LANs. Point-to-point is typically serial, like point-to-point protocol, HDLC, and some others. But we'll talk more about that in just a moment. So media access control regulates how we actually access the medium. How do we actually place data frames onto the media? What are the rules? What if two devices want to send at the same time? Okay, so point-to-point versus multi-access. First of all, point-to-point networks like protocols like PPP and HDLC. I like to think of this as like a pipe, like we have here, right? Pipe or a hose. You put in information in one end, it's only going to come out the other end. That's the only place it's going to come out. It's like having two people in the room. Let's say it's just you and me. And all I do is say, I owe you $10. Well, you know when I say that I'm referring to you because you're the only other person in the room. Multi-access networks like Ethernet have multiple nodes on the exact same network. So when information comes into this pipe, there's many different exit points it can go out of. It might go out just one of these or all of these. It just depends. We'll talk more about that when we get into Ethernet. But the important thing here is that when you send information on an Ethernet network, the possibility of multiple devices receiving that information is very probable. So you have to be very specific who you're addressing this information for on that specific network. Let's go back to the analogy of me saying I owe you $10. What if there's 10 people in the room? And I say, I owe you $10. Well, everybody's wondering, who am I talking to? Am I talking to everybody in the room or somebody specifically? So I actually have to specifically say who I am addressing. I might say, Allegra, I owe you $10. So assuming that there's only one Allegra in the room, everybody else that might have heard me say it go, well, Rick is talking to Allegra. I heard the information, but Rick didn't mention my name. So this information, doesn't concern me. Okay. All right. And we're going to be talking much more about that when we get into Ethernet. Okay. So again, a multi-access technology enables a number of nodes to communicate on the same network. And we typically do that. Let me kind of use my pen here, and we'll see this a lot more with when we get into Ethernet, but I might have many devices here. Okay. And originally, all these devices here were connected to the same physical cable. We'll talk more about this when we get into Ethernet, but it was just one long cable, and they use these transceivers that we called vampire taps actually tap into the line. So when information was sent, it would be sent out both directions, and everybody connected to this cable would receive it. Today's networks use something called, or today's Ethernet networks use, and we're going to talk more about this in more detail later, use things called Ethernet switches. So the network interface cards, that's what we have in here, are connected to the Ethernet switch. Okay. Now it's staying, we'll talk more about this later, but the possibility still exists that if we have computers A, B, and C, that A may be sending information to B, but it's possible that C might receive it also. So we have to, at the data link layer, specifically say who we want this information for, because we don't want every device having to process the same information, whether it's intended for that device or not. Okay, so how do we do that in Ethernet per se? So using a and this kind of any kind of multi-access network, but Ethernet is the one we're most familiar with in Ethernet LAN. So first of all, I just want to mention that these devices here, it shows that they're all connected to like one long cable, but think of everybody here connected to the same Ethernet switch. Okay, and we'll talk more about that when we get into Ethernet. Okay. But what I want to show you here is we have this device here, it's like computer A wanting to send a data link frame to, let's call it computer B over here. Now the data inside here, this is typically where we're going to have our IPv4 or IPv6 packet. And that will have the IP addresses, the network layer addressing in the data, in part of the IP header. But what Ethernet is all about, again, is NIC card to NIC card communications. So the NIC card in this device sending to the NIC card in this device, the Ethernet NICs. So we need a way for this device, when sending the packet in the Ethernet frame, that this device here, computer B, knows that this Ethernet frame is for it. So in the Ethernet frame, we have some addresses, data link addresses. In Ethernet, we call these Ethernet MAC addresses. We'll talk more about that later. But notice that the source data link address, source MAC address, is the NIC card address of A. And the destination data link address, the destination MAC address, is the Ethernet MAC address, the data link address of B. Those are addresses that are embedded on the NIC card physically. So even if these other devices receive the frame, like 3333, when it sees that the destination address, the data link address, is a different address, it will ignore the rest of the frame. Go, oh, I don't have to copy the rest of this in, it's not for me. However, when B gets it, it will see that 6666, the destination MAC address, is its MAC address, and will say, oh, this Ethernet frame is for me, and it will copy in all the information. Okay, we'll discuss this a lot more when we get to Ethernet. Okay, so in point-to-point networks, when we talk about addressing, things are a lot simpler. Remember, so let me kind of back up one more here. Think of this as the same analogy, the multi-access, as Rick talking to, there's 10 people in the room. Okay, I have to specifically address who I owe that $10 to. Here, there's only 2 people in the room. It's that pipe, right? Information comes in one end, goes out the other. So as far as the data link address for a serial protocol, for a point-to-point serial protocol, it's much simpler because it's basically, in this case, it can be like just all 1 bits. It's just, hey, you. You know, I don't have to know your NIC card address. You're the only one at the other end of this pipe. You're the only other person in this room. So we don't require any special addressing with point-to-point links. Okay. All right, so I hope this helped understand a little bit about data link layer access in the media. Again, we're going to talk a lot more about this when we get into Ethernet.